Many people assume that to start learning cybersecurity, you need an expensive, high-end laptop. Without that equipment, the entire field can seem unreachable. But the device in your pocket is already a capable computer. By loading a specific suite of software, you can configure a standard Android phone as a portable command line testing environment. By the end of this session, you will know how to use your phone to track a location, run a phishing simulation, and map local Wi-Fi networks. Everything we cover today is strictly for educational purposes. You must only run these tools on networks you own or where you have explicit permission to test. Operating these tests from a phone allows anyone to begin learning defensive tactics from anywhere, providing a practical entry point into cybersecurity education. Step 1 is getting the terminal app, Termux, onto your phone. You want to bypass the Google Play Store version as it is no longer supported and causes repository errors. Instead, download the Termux APK directly from their official GitHub via your web browser. Once you open the app, you need to sync the system. Type apt update and then apt upgrade to ensure you are working with the latest server data before installing anything else. Now install the core programming languages and utilities we need. We will install Git, followed by PHP, then grab wget, and finally Python. After downloading those packages, your screen will be cleared. Type clear and hit enter to sweep away the text and create a clean, readable workspace. Adding these specific languages and tools removes the limitations of a standard consumer operating system. Your phone is now an open developer environment ready to run custom scripts. For our first objective, we will simulate device location tracing. We are going to clone a repository called Hound from GitHub directly into Termux. Navigate into the new folder by typing cd hound. Then, execute the bash script by typing bash hound.sh. This action initializes a local server right on your phone. The script will load and output a secure HTTPS URL. This link is our tracking payload. This diagram illustrates what happens on the receiving end. When a target opens this URL, their browser prompts for location permissions. The moment they click Allow, that grants access to the device's GPS. Those exact coordinates are sent directly back to your Termux window. A single careless click on an unknown link, combined with a habit of hitting Allow on browser pop-ups, exposes precise physical location data in seconds. Next, we'll run a credential harvesting simulation using a Python-based tool called PyFisher. Just like before, use the git clone command to pull the repository. Type cd pyfisher to enter the directory, and start the program by typing python pyfisher.chi. The program displays a numbered list of templates. We'll type 07 to select the Instagram 1000 followers option, creating a specific visual lure to test human vulnerability. Look at this split screen. On the left is what the recipient sees when they open the generated URL. The layout and branding look exactly like the authentic interface, prompting them to log in to claim free followers. Thinking they are logging into the real site, the user types in their details. For this test, we will input a sample username, like Aman, and a random string for the password, then hit login. The page instantly redirects to the real Instagram site, avoiding suspicion. Meanwhile, back in your Termux window, the username and password you just typed appear in plain text. We didn't break any complex encryption or hack the platform's massive servers. We simply replicated a digital interface, proving that visual deception can bypass technical defenses by targeting user behavior instead of the code. For our final task, we will map a local Wi-Fi network. We'll use Nmap, an industry-standard network discovery tool. Install it by typing pkg install nmap. To know where to scan, we first need to locate our own position on the network. Type ifconfig to reveal your phone's current local IP address. This diagram shows subnetting. Take your IP address, like 192.168.1.5, and swap the final number for .0/24. This instructs Nmap to sweep the router. Execute the command, and the tool maps the network, listing the IP addresses of every device sharing your Wi-Fi. Mapping the environment is always the first step in a security audit. You cannot properly secure your network or understand its vulnerabilities until you know exactly what hardware is connected to it. In under 6 minutes, we installed a developer environment on a stock Android phone and used it to track locations, capture credentials, and map a local network. Holding these tools on a device you carry every day is a significant responsibility. These techniques exist to show you exactly how attackers operate, so you can test and build defenses for your own systems. This was only the foundational layer. In Part 2, we will move past the basics and explore advanced Termux modules alongside more complex tactical scenarios. Cybersecurity expertise is built on understanding how digital systems interact and exploring those connections with an ethical mindset, regardless of the hardware you use.